Welcome friends. Today we are going to learn mechanical optical comparators. In previous lecture we have seen mechanical comparators, different types of mechanical comparators. Today we are going to learn mechanical optical comparators. So this is one diagram which I have shown here for mechanical optical comparator. Let us learn about mechanical optical comparators today. Basic principle of mechanical optical comparator. Working principle of optical comparator is based on the laws of light reflection and refraction. We know that laws of light reflection and refraction falls in principles of optics. In mechanical optical comparator, small variation in the plunger moment is magnified first by mechanical system and then by optical system. So wherever mechanical system and optical system both are combined, then such a comparator is called as mechanical optical comparator. So it makes use of both mechanical system also and optical system for magnification of a signal. According to the law of reflection, let us see the figure first. So when a ray of light is incident on a plain glass reflector such as mirror at an angle theta to the perpendicular normal, then the incident ray is reflected at an angle theta to the normal. And if we see the total angle in between the incident ray and the reflected ray, then it is twice of theta. So this is what is a generalized principle. If we tilt the mirror, now see figure B, tilted position of mirror is shown. The mirror is tilted by an angle alpha. So incident ray, when it is getting incident on the mirror at an angle theta plus alpha, then it will be reflected at an angle theta plus alpha. So total angle of reflection between incident ray and reflected ray 2, it is twice of theta plus alpha. It means twice of theta plus twice of alpha. So double the magnification. So this is what is the basic principle involved in optical comparator. So this is what is one figure which I have shown here for mechanical optical comparator. Here is the arrangement shown for mechanical optical comparator. It consists of light source, condenser lenses, projection lens, a plain glass reflector which is called as mirror here. Mirror is supported with a hinge, and this mirror is supported at other end by making use of a plunger. Now see, the plunger is both sided plunger to support the mirror and plunger to sense the workpiece surface. See here, the figure is quite self-explanatory. There are two systems in this figure. First system, if you see from light source up to the mirror, this is optical magnification system, and second one is plunger with hinges. It is shown for mechanical magnification system. So workpiece which is there, it is kept below the mechanical plunger first, and whatever are the surface features or say differences in the dimensions for workpiece, those are sensed by the plunger. Of course, the workpiece dimensions are compared with always standard dimensions. So if there is a difference between the standard dimension and workpiece dimensions, then those will be sensed by the plunger. The plunger which is in contact with workpiece, it will magnify it by certain mechanical magnification, and this change in dimension difference which is there, it is again magnified by the optical magnification system. Let us see here. In mechanical optical comparator, small displacement of the measuring plunger are amplified force by mechanical system consist of pivoted levers. The amplified mechanical moment is further amplified by a simple optical system involving the projection of an image. Mechanical system causes a plane reflector to tilt about an axis, and the image of an index is projected on a scale on the inner surface of a ground glass screen. Optical magnification provides high degree of measuring precision. So what are the important points in this mechanical optical comparator? So in this system, mechanical amplification from the figure is equal to x2 by x1. Optical amplification is equal to x4 by x3 multiplied by 2. It is always twice as per the principle of reflection of light. It is multiplied by 2 because if mirror is tilted by an angle delta theta, then the image will be tilted by twice of delta theta. So overall magnification of the system is multiplication of mechanical amplification or magnification and optical amplification or magnification, that is equal to twice of x2 by x1 multiplied by x4 by x3. So this is what is the overall magnification of mechanical optical comparator. So here I have shown another type of mechanical optical comparator, that is Zeiss ultra optimeter. The basic principle involved is again same, but slightly the arrangement here is different. The figure itself is self-explanatory, so please go through the figure. You can have the image of figure and you will get the self-explanation from the figure. Let us move further. What are the advantages of mechanical optical comparators? So first one is it has small number of moving parts, hence a higher accuracy is there with mechanical optical comparators. Second is in the optical comparators the scale can be made to move past a datum line and thus have high range and no parallax error. So it means what? Parallax errors here are removed. Third one is it has very high magnification. Fourth is optical lever is a weightless item, so the weight of system becomes less in case of optical magnification system. What are the disadvantages of mechanical optical comparators? First disadvantage is on the need of high magnification, more heat from the source of light may cause the setting to drift. Means drift errors are involved in these comparators. Second one is an electric supply is necessary to operate the source of light. It means it is a passive comparator. Third one is it is costly and bulky in design. So from volume point of view, the comparator is bulky one. And fourth one is instruments on which the scale is viewed through the eyepiece of a microscope are not convenient for continuous use. It means it causes fatigue to observer's eye. So these are the disadvantages of mechanical optical comparators. So these are the references. You can refer these books for further readings. So here we will stop. Thank you.